So let's have a look at this question. Now, this question is similar to what we had done in this question. See, these square roots will scare you, but it's a pretty simple question. Now, secant a minus 1, secant a plus 1, secant a plus 1, secant a minus 1. See, one thing that you need to understand, there's a simple rule that you need to understand. Root 2 multiplied by root 2 is equal to root 2 into 2 into 2. What this means is that, you know, if there are same numbers that come under a square root, the answer is the number itself. So I'll be using this concept when I'll be doing this question. So let's start. Another thing that you can understand is for people who find difficulties in square roots, because I've seen a lot of kids face difficulty in square roots. So this is equal to root a upon root. So if there is a square root on a fraction, so if there is a square root on a fraction, it the square root can be broken into numerator as well as denominator. So for example, if you have something like this, square root of 4 upon 3 can be written as square root 4 upon square root 3. So this is something that I need to discuss before we start doing this question. And of course, another thing that I want to discuss is, yeah, that should be enough. Okay, let's start. So first I'll break this into two. Secant a minus 1 upon secant a plus 1. So I'm breaking the square root. Secant a plus 1 upon secant a minus 1. So I've broken the square root. Now I'll take the LCM. How I'll take the LCM is, this would be secant a plus 1 multiplied by secant a minus 1. And now when I have to take the LCM, see this root secant a plus 1, this is root secant a plus 1. So I have to multiply this. I have to multiply this term with this term. And because the square root, under the square root, the same number would be there. This is what I was trying to tell. So root secant a minus 1 into root secant a minus 1 would be equal to secant a minus 1. The same rule as saying root p into root. If we are multiplying the square roots of the same number, that is equal to the number itself. So this is done. Now let's look at the next term. So secant a minus 1, secant a minus 1. So here it will be root secant a plus 1 into root secant a plus 1. This will be again equal to secant a plus 1. Now this minus and plus will cancel, and this will be equal to secant a plus secant a. This will be equal to secant a upon. So this is, if you look closely, this is a plus b into a minus b. A plus b into a minus b is a square minus b square. Will be, the root will remain, will be equal to secant square a minus 1. Hope this is making sense. Now when you look at this, we understand that 1 plus tan square a is equal to secant square a. So secant square a minus 1 will be equal to tan square a. Secant square a minus 1. So this is equal to tan square a. So I can replace this secant square a minus 1 by tan square a. So let me do it here only. Tan square a, and root of tan square a would be equal to tan a. So the square root will vanish. This will be tan a. Now again, if I look closely at this, 2 secant a can be written as 2 upon cos a whole upon tan a can be written as sin a upon cos a Now, this can be written as, let me make some space here. Again, a lot of students face difficulty when they see something like this, but this is very easy to understand. See, so let me solve something like this: 3 upon 4 divided by 5 upon 3. So how do we solve this? We write this as 3 upon 4 divided by 5 by 3. This is just to explain. So 3 by 4 into 3 by 5, 9 upon 20. So basically, this fraction divided by this fraction would be equal to the numerator multiplied by the reciprocal of the denominator. So here it was 5 by 3. Here I have written 3 by 5. So this is how these kind of divisions are handled. Now, as I have been discussing, see, proving the trigonometric identities, it is more to do with the algebra rather than trigonometry, because the trigonometry part is easy. It is the algebraic manipulation which gets difficult. So this will be equal to 2 cos A, the numerator, multiplied by the reciprocal of the denominator, cos A upon sin A. This cos A will cancel. So this will be 2 upon sin A, and this will be equal to 2 cosecant A. 2 cosecant A is what is equal to the RHS. This is equal to. So that is what I was trying to tell you, that this question and this question, they are almost the same. For this question also, if you look the question, we did something like this. Finally, this was equal to 2 secant A. Scary. Both of these are scary looking questions, but if your algebra is fine, they can be done easily. And in trig identities, it's the algebra which is a core issue. It's not the trigonometry. So let's move to the next question.